Hello, my name is Ethan Liu, and I will be presenting a piece of art for y'all today. I've titled my piece of work, Chemistry, My Passion. Do you like science? Do you like chemistry? Do you like Miss Turner? Yes, yes, yes! Well, let's dive right in. There's so many topics and so much fun. Honestly, I see no difference. I see the same. My eyes are opened wide, wider than you've ever seen. Heat transformations and energy transfer. Some might ask, what is the law of conservation of energy? And with Miss Turner's help, I now know energy cannot be created nor destroyed, but it can be changed from one form to another. For real though, this just means that a system always has the same amount of energy, unless it's added from the outside. Now you ask, what's kinetic energy? What's potential energy? I don't know. Well, bros, let me tell you, let me let you in on a secret. Kinetic energy is energy of motion. Potential energy is stored energy. That's the difference. So what's the same? I don't know. Just kidding, I know, because Miss Turner's my teacher. They're both types of energy. Mechanical energy. There's so many more types. Mechanical energy is the energy of motion and position. It's the energy acquired by the objects upon which work is done. Identifying mechanical energy is pretty simple for real. It ain't too hard, no cap for real. I ain't even capping dog for real. You can tell easily. Just see if there's movement and look at its position. I mean, it's in the definition. You want examples? I'll give you examples. Steam and a ball rolling. Thermal energy is the energy of the motion of atoms, molecules, and ions. I'll explain something real quick for real. What to the wise? If there's heat, it's thermal energy. If it's hot, if there's heat, just know it's thermal energy. The only example is heat, and more heat. Electrical energy is energy of electrons moving through a conductor. The faster the charges move, the more electrical energy they carry. You can tell if it's electrical energy when electricity is moving through a wire. Radiant energy is energy from the movement of electromagnetic waves. If it's coming from the sun, it's radiant energy. Radiant energy is clearly shown. All you gotta look out for is light, microwaves, radio waves, UV, X-rays, and gamma rays. Just a few examples tossed here and here. Sound energy is energy from vibrations of matter. Sound is produced when a force causes an object or substance to vibrate. The energy is transferred through the substance in a wave. Anything you can hear, anything where use your ears, it's sound energy, I said sound energy. Some examples might be fire popping and gas hissing like a snake, Paul and Danilo. Gravitational energy is potential energy due to an object's position, like its height above the ground. When things fall, gravitational energy is being used. You can see it everywhere. Just look around. Look around and you will see it everywhere. Some examples include a ball sitting on top of a hill and a yo-yo in your hand. This ain't even on the rubric, but I is such a good student for real, so I'm gonna include this jink jack. Chemical energy is the potential energy due to the attraction and bonds between atoms and molecules. Now, onto electrostatic energy. It's potential energy based on the position of charged particles and the fact that charged particles repel and attract. You can see it all around you, everywhere that you go. You can tell them where there's lightning involved. Just open your eyes nice and wide. Examples may be a capacitor and clouds and ground before lightning strikes. Finally, nuclear energy is potential energy from the forces that hold together the nucleus of an atom. You can see it in elaborate science things. One time a bad man used nuclear energy. His name was Adolf Hitler. He tried constructing an A-bomb, atomic bomb. Examples include fission, fusion, stars, and an atomic or hydrogen bomb. Conduction is thermal energy from the gases in the flame can be produced pass to air particles near the flame. This causes the molecules to move faster and faster and collide more often, pushing the molecules farther away from each other. A current develops in the air above the candle as warm air rises and cool air falls. This be called convection for real. Convection can occur in fluids like liquids and gases. Some examples might be boiling water, a radiator, steaming cup of hot tea, and ice melting. The flame transfers its thermal energy, and ice melting. The flame transfers its thermal energy to the atoms on the end of the metal nearest the flames. These begin to vibrate more and hit against the atoms next to them. As the atoms collide, the thermal energy moves down the metal until it reaches the wax. This is called conduction. Conduction generally occurs in a solid. That means it has a definite shape and a definite volume. I learned that from Miss Turner. For real. Not even capping though. And some examples be like a spoon touch a little baby bear soup. Or even my boy Paul boiling tea on his stovetop. Radiation is the emission and propagation of energy in the form of rays or waves. The energy radiated or transmitted in the form of rays, waves, or particles. Radiation is how heat moves through outer space from the sun to the earth. It is also why you feel heat on the side of a candle flame. An example of radiation. There are so many. The sun looking down at the world. It's like Miss Turner looking down at me, and Miss Rhodes looking down and up to Olivia. But just kidding. Some actual examples could be a Bunsen burner and a can. If it's physical, it's conduction. If it's air is rising, it's convection. If it's everywhere, it's radiation. There's so much fun in chemistry. Miss Turner is the best teacher of all time. Now on to more fun, which nobody thought was possible, but about to prove y'all wrong for real. I'm always right, I'm never wrong, except when Miss Turner tells me I am. Or even Miss Rhodes. Fire triangle is so much fun. There are 3 sides to a triangle. Tri means 3, angle means angle. As you can see, I got an A in geometry. Hall of Fame. Heat, oxygen, and fuel. Just remember Hall of Fame. If any one of these are missing. Just remember. The fire will go bye-bye, and bye-bye, it will go out. You need all 3. Each element of the fire triangle is necessary. Necessary, I say. Fire needs oxygen to keep it going, and needs heat to be hot, and needs fuel to start. It's quite the combo, like me and Danilo. You like science? Do you like science? Do you like chemistry? Do you like Miss Turner? Yes, yes, yes. Chemistry is fun. I do it all the time. One lunch, weekends, math class, and more. I never need a break. It's so much fun. I want to go to Ocean Lakes with you, Miss Turner. You, I say. It will be the most of fun. I chose AP Chem. Miss Turner went, see ya. I dropped AP Chem. I love chemistry. I love Miss Turner. Singing is my passion. Hello, my friends of Virginia Beach, Class 4A. It's Ethan Liu, and I'm back at 2:59 a.m. with a new composition for you all to enjoy. This up-and-coming artist, Ethan Liu, or me. Well, I'm just gonna let my bars flow. It's from the heart. What up, y'all? Yo, it's Ethan, and I'm back with some mo. For real, no cap. I've been cooking up in my studio, and I brought back a track. This time in no whack energy transformations. I brought some lit endothermic and exothermic reactions and enthalpy. This be lit. Do you love chemistry? Do you love Miss Turner? Do you love learning? Well, yes. Endothermic reaction be a reaction that absorbs energy and makes the temperature of the surroundings go down. It feels cold to touch. Ooh, chilly. Exothermic reaction is a reaction that releases heat and makes the temperature of the surroundings increase. It feels hot to touch. Ooh, sizzle. If the reaction is endothermic as written, an increase in temperature will cause the forward reaction to occur, increasing the amounts of the products and decreasing the amounts of reactants. Lowering the temperature will produce the opposite response. For an exothermic reaction, heat is essentially a product of the reaction. If you increase the temperature, you are increasing the amount of product, so you shift the balance at the equilibrium back towards reactants, meaning there will be more reactants left at equilibrium. An exothermic reaction occurs when the temperature of a system increases due to the evolution of heat. In an endothermic reaction, the products are higher in energy than the reactants. Therefore, the change in enthalpy is positive, and heat is absorbed from the surroundings by the reaction. Exothermic is when there is less heat, which means the heat is being absorbed by the reaction. Endothermic, a reaction releases heat, which means the temperature of surroundings go up. Q equals heat, M equals mass, C equals specific heat, delta T, Q, M, cat, Q equals M cat, delta T equals temperature change, final temperature minus initial temperature. When heat is decreased, it's an exothermic reaction. When heat is increased, it is an endothermic reaction. Now, what is enthalpy about? Y'all might ask. For real, I don't even know though. That's why I did a little bit of research. That I had to do. So, in fact, it is a thermodynamic quantity equivalent to the total heat content of a system. It is equal to the internal energy of the system plus the product of pressure and volume. Now I'm going to tell you how to get down. I'm going to tell you how to use the enthalpy of reaction to determine how much heat is being absorbed or released by a substance or reactions. So, don't be fooled. There are lots of steps, and I mean lots. Step number 1. Determine reactions, products, and reactants. Step 2. Determine the total mass of the reactants. Step 3. Find the specific heat of your product, or C. Step 4. Find the difference in temperature after the reaction. Step 5. Use the formula delta H equals M times S times delta T to solve. Last but not least, certainly not least, step 6. SACE. SACE. Determine whether your reaction gains or loses energy. So many parts to chemistry, some more challenging than the others, but always fun, I swear to. Chemistry. It makes your brain work harder and harder and harder and harder. Your brain will get bigger and bigger and bigger and bigger. That's what she said. I love chemistry. My heart pounds for chemistry. It's so fun. Endothermic and exothermic was so hard to understand. My mind was like, it's like math. I couldn't understand it. Now that I get it, it's such a relief, for real. I didn't even cabin though. Thank you, Miss Turner. Thank you, 4A. Thank you, Virginia Beach. This is Ethan. I'd like to conclude my album today of chemistry, my passion. I'd just like to take the time today and thank you all for just coming out, taking the time to listen to what I really poured out from my soul, and just like wanted to share my knowledge with you all. I just hope you guys can take that to heart and just use it in your futures, and just, I know your futures will be bright, and I believe in you guys. I really do believe in you. And Miss Turner, I love you. Thank you for everything.